Welcome back again. Once again, this is Mr. Spinks, and we are on the second of our videos about Section 2.1 in NAM's class. Now, this one is about sets, once again, because 2.1 is all about sets. But this is ways to represent or express a set, a big thing that we're going to be emphasizing on the test. So here we go. Now, there are three specific ways that you can emphasize or really describe a set. The first one is the descriptive form. Now, to do descriptive form, all you do is describe but not listing all the elements of a set. As I have my typing problems. And I'll give you an example here, of course, to try to help out, because initially that doesn't help out a whole lot, but let's talk. What is an example of this? Well, let's say we use as an example the set of all positive even numbers. Notice how here we're talking about what it is, we're describing it, but I did not say what the positive even numbers are. I didn't list them, I just actually described the set. That's a description format. Next up, we're going to talk about roster format. And roster format is pretty much the opposite of a description format. Because with roster format, all you're going to do is you're going to pretty much list the elements of the set within braces. Wow, typing issues again. Okay, and once again, we will use an example in this case. I will show you an example from what we previously talked about. If I wanted to just use a roster form for my previous example, the set of all positive numbers, the way I would do it, I would set up an actual brace going on in this case. Let me get my writing tool, excuse me. So we've got a brace, that's a brace, my example of a brace, and we just list out the actual elements of the set. So if it's positive even numbers, it is 2, wow, look at my writing, 4, 6, 8, 10, and it goes on forever because positives go on forever. To indicate going on forever, I will do the ... and close the brace. That's an example of roster form. Once again, we don't describe them, we just actually list out all of the elements of the set. The last one we're going to talk about is set builder notation, and this is the trickiest of them. A little bit tougher one, but not hard whatsoever at all. Definitely something to focus on. So as we talk about set builder notation, when we do set builder notation, basically to do this, I'm just going to give you an example of what it looks like. I'll give you a couple of them in this case. First off, you start out by actually giving it an actual letter or a name. We will call our set set A. Next thing you do, you set up a brace, just like you did, always happens. Now, the elements of your set, you should give a variable. We will call the elements of our set X. There's always a line that goes on right here. This means such that. So all of the elements of the set A are X such that. Then we tell them about an actual condition. Well, in this case, we had positive even numbers. Well, if it's positive, X is an element of the positive even numbers. Well, positive numbers are automatically natural numbers, and we will talk about that in just a second. I would use an N right there for natural numbers. Moving on from there, what do I know about my natural numbers or my positive numbers? Well, they must be even in this case. So X is the set of all natural numbers, and X is even. Easy stuff. Simple setup going on right there, okay? That is set builder notation. And we'll do a couple of examples to show you set builder notation because it's the tougher of the actual sets. Now, we've got to talk about a couple of things in this case. We've got to talk about natural numbers, whole numbers, and integers, because in order to do set builder notation, you will need to know what these are. So, what are natural numbers? Well, natural numbers are positive, whole numbers. Whoop. That's what they are, positive whole numbers. And I'll give you an example on what positive whole numbers are. Positive whole numbers, of course, in this case, do not indicate 0. It is 1, 2, 3, 4, 5, and all the rest of them, dot, 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 going on in that case. That's what natural numbers are. In order to signify natural numbers, we use n as the actual symbol for them. Moving down to whole numbers. Whole numbers are also positive numbers and 0. So basically all natural numbers and zeros. What are we talking about? Can't be fractions, can't be decimals in this case. So we are essentially talking about, rather than just 1, 2, 3, 4, 5, 6, we're talking about 0, 1, 2, 3, 4, dot, 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 dot. That's what we're talking about with whole numbers in this case. So you got to have the terminology. Natural numbers are just the positives. Can't be decimals, can't be zero. Or can't be decimals or fractions or 0. Whole numbers are positives and 0. And then we come down to integers. Now, for whole numbers, our symbol that we will use is a W. We keep this real simple. Okay, W is our symbol. IMB. That we will use for whole numbers. Last one, what are integers? Integers are negative, 0, or positives. But we cannot have no decimals or fractions. So what are we talking about in that case? Well, essentially what we're talking about with integers, example, is -2, -1, 0, 1, 2. Can't be fractions, can't be decimals, but positives or negatives. And I use the dot, dot, dot in either direction to show that it goes on either way. Our symbol for integers is just going to be an I. Go through a couple of examples. Write a description of the set containing January, February, March, April, May, June, July, August, November, September, October, and December. A little out of order. This is the set of months. Easy stuff. Coming down to the bottom one, we have specific months in this case. June, July, and August. This is the set of summer months. So again, we are describing them in this case. Easy stuff going on right there. Moving on to the next example. If we wanted to express these in roster format. In roster format, we would simply write out what they are. So our set is A in this case, and it includes whole numbers less than 6. So what are whole numbers less than 6? Well, it can't be 0 or negative. So 1, 2, 3, 4, 5, and 6. Well, hold on. It's less than 6, not less than or equal to. So we get rid of the 6 in this case and close the set. There's our set A in that case. And it is in roster format because I just listed the elements. So example B, we have set B. Whoa, fun with a pen. And set B is all integers in between -1 and 4 inclusive. Now that word inclusive means it includes the -1 and the 4. So we've got to go from -1 to 4 and include those numbers. Roster format just lists the elements of the set. Easy stuff going on right there. The last one we want to do is set builder notation. This is a tough one, so watch. We start out with set A, that is the set. Now, it is the set of all x's such that always happens. X is an element of, now you look and say, are these natural numbers, integers, or whole numbers? Well, they're all positives and there's no 0. So they are natural numbers, and you put a condition on it. What's our condition? Well, our natural numbers are less than 10 is one way to do it. Okay, there's a couple of ways to do it, but all these numbers are less than 10, and therefore that's an example of set builder notation. Give you one more here on the bottom, our last one. The set is set B, and the set B is all x's such that, this happens every time, x is going to be an element of, well, you look, these are negatives and 0. Well, negatives and 0 indicates they are integers in this case. And what do we know about our integers? Well, integers can be negatives, positives, or 0. So you got to look on both sides of this. our x is greater than or equal to -4, and our x is also less than or equal to 0. Set builder notation. These are some examples. We'll go over a few more in class just to make sure you understand it.